This training video is provided as a service tool for technicians and self-maintained end users. It contains information on the basic operation of vehicular repeaters, a functional description of the multi-vehicle format, and necessary alignment procedures prior to installing an SVR-200 into a vehicle. The program is divided into 7 sections. Section 1 covers basic operation and multi-vehicle format. Section 2 covers programming the SVR-200 prior to installation. Section 3 looks at the disassembly of the SVR-200, location of the major components and test points, and introduces the technician to the pyramid test fixture as an aid for alignment and troubleshooting. Sections 4 and 5 provide in-depth instruction for alignment of the SVR-200 both on the bench and when connected to the mobile radio. Section 6 explores the use of the front panel LEDs for verification of proper operation, as well as troubleshooting problem situations. Finally, Section 7 introduces some techniques for determining RF interference and methods that can be used to eliminate it. By the end of the video, the technician should understand all of the SVR-200 functions, be able to program and align the unit prior to putting it into service, and be able to determine if the unit is operating properly, and be able to diagnose the problem if it is not. Vehicular repeaters extend the range of handheld portable radios by connecting to an existing high-power mobile radio and repeating transmissions in both directions. Generally, vehicular repeaters are used as mobile extenders in crossband operation. The SVR-200 to portable link is VHF-UHF simplex, and the mobile is low-band VHF or UHF. The mobile may be trunking or conventional. In-band operation, while not recommended, is possible, but care must be taken to prevent interference between the mobile's high-power transmitter and the SVR-200 receiver. Proper frequency selection and antenna placement are important even in crossband operation, but especially for in-band use. The antennas should be spaced as far apart as practical with vertical separation if possible. The SVR-200 is designed to operate on simplex frequencies that must be different from any frequency in the mobile. Part of the multi-vehicle format dictates that all of the SVR-200s in a system must be able to monitor traffic on the link frequency to determine when a handheld is transmitting or if other SVR-200s are transmitting. The handhelds will transmit CTCSS, but should be carrier squelch receive. The SVR-200s do not transmit CTCSS, but are tone protected on receive. If set up this way, the SVR-200 will be able to tell the difference between a handheld transmitting and other SVR-200s transmitting. When the user leaves the vehicle, they activate the SVR-200. When their mobile radio is receiving a transmission from the base, the SVR-200 will repeat the transmission on the handheld's receive frequency. If the operator transmits on their handheld to the SVR-200, it will key the mobile radio and rebroadcast the signal at high power back to the base on the mobile frequency. As long as the user stays within range of the vehicle, they will have the same coverage as their high-power mobile radio, but using a low-power handheld. The SVR-200 can be programmed to give the handhelds priority in a conversation by periodically checking for handheld transmissions, carrier and tone, using priority sampling. During base to portable transmissions, the SVR-200 will periodically unkey for a brief time to check for handheld transmissions. If detected, the SVR-200 will cease transmission, key the mobile radio, and repeat portable to base. This allows the handheld to respond during hilltop repeater hang time and prevents lockout if the mobile squelch were to remain open. When the SVR-200 is first activated, it will transmit a short lock tone that alerts the user that the system is functioning. It will then assume the priority status and be ready to repeat any portable to base or base to portable transmissions. If another unit arrives on the scene and is activated, it too will transmit the lock tone. When the first SVR-200 detects the lock tone from the second unit, it will increment a priority counter and will no longer repeat any transmissions. The recently arrived unit will be the priority repeater, and the first unit will be one count away from priority. This process will continue for each unit that arrives on the scene, creating a priority hierarchy for up to 256 vehicles, each with a unique count and only one unit at a priority status. The SVR-200 will not transmit its lock tone if the radio channel is busy when first enabled. It will wait in non-priority status until all transmissions cease, then send its lock tone and become the priority unit. This method is commonly referred to as last man out. Even though the other SVR-200s are not at priority status, they will continue to monitor the channel for activity. If the priority unit were to leave the scene or become disabled, the other units will detect the condition to repeat and determine that there is no priority unit repeating the transmission. They will then begin to decrement their priority counters until one of them reaches the priority status and begins repeating the transmissions. Since the SVR-200s are all at different counts, only one will reach priority status and begin transmitting. The other units will sense the new priority repeater and cease counting down, preserving the priority hierarchy. If another unit were to arrive from a different scene and it is still the active priority, there will be two active repeaters on the air when a condition to repeat exists. When one of the SVR-200s unkeys to check for handheld activity, it will detect the presence of the other active SVR-200 and increment its priority counter and cease transmission. This is the self-clearing mode to prevent radio collisions. If the handheld operator is out of the vehicle and their partner still in the vehicle were to key the mobile radio using the local mic, the SVR-200 will detect the local push-to-talk and repeat the transmission to the other handhelds so that both sides of the conversation will be heard by everyone on the link. The local mic repeat function can be enabled and disabled via the PC software. The SVR-200 also has a local receive audio speaker jack that enables the person in the vehicle to monitor handheld to base transmissions that are being repeated through the mobile. If the users wish to communicate handheld to handheld without accessing the mobile repeater, they may transmit on the same frequency without CTCSS or a different CTCSS. The SVR-200 only responds to carrier and proper tone from the handhelds. We're going to explain the programming and PC hookup to the SVR-200 in order to personalize the radio. We'll go through the software, all of the menu items, and show how to make the connection to the SVR-200. The personalization software is called SVR-200. From the DOS prompt, you would type SVR-200, and there are a number of options when starting the program. You can view those options by typing -H for help. You can select a different COM port, either 1 or 2, as the initial COM port. You can also change it within the program. The -B option will force it into black and white mode. On some of the VGA black and white LCD screens, there aren't enough colors to display properly, and you won't be able to see some of the menu highlights. If you have that problem, use the -B command line switch to force it into black and white mode. We're using a color screen, so we don't have that problem. We start the program with SVR-200. After the program starts, you can select a menu item by clicking the left mouse button on that item, pressing the first letter of the item on the keyboard, or by moving the highlight to the item with the cursor keys and pressing Enter. Pressing Escape will always back up one level. The program functions are all grouped by category. All of your file functions are in the first pull-down menu. You can load a configuration from disk. You can save your configuration to disk for later recall. You can select the COM port, either COM port 1 or 2, or You can print out the information on your dot matrix or laser printer. The data menus allow us to change the RF frequencies and tones. The common data is for configuring the SVR-200 for each type of mobile, such as input-output polarities, and enabling or disabling user features. Most of this information is contained in the application note available from Pyramid. The radio menu will allow you to send the data to the SVR-200, read the information from the radio, and to change the frequency band. And, of course, you have your help menus. The General Help explains how to use the program. About contains version information and how to reach us. The first item you will want to select is the frequency band for the SVR-200 you'll be working with. We're using a UHF radio which is set for 400 to 500 megahertz. Next, we will want to set up the transmit and receive frequencies using the Data menu. This is our transmit frequency. To change the frequency, simply enter the digits such as 460.525. The receive frequency is done the same way. The tones are programmed in the same manner. Normally, we would not have an encode PL. The SVR-200 is designed to operate decode only, and you select the PL tone here. You can type it in directly, the same as the transmit and receive frequencies. If you type in a wrong code, it will bring up a window with all of the possible tones, and you can select the proper tone using the cursor keys. When you have entered the correct frequencies and tones, press Escape to exit and select the Common Data menu. The first item is the file name. This is the name that is stored in the repeater for later recall. It will show up in the printouts, and it is the name that is suggested when you save the data to disk. The COR polarity is the polarity of the signal coming from the mobile that indicates when it is receiving. That's our indication to transmit, and it may be high or low. To change the selection, press the Enter key. The radio type can be selected as conventional or trunking. If the SVR-200 is connected to a trunking mobile, there is one additional line that senses when the mobile transmitter is actually on the air and is used to determine when the mobile has acquired a voice channel. We'll be connecting up to a conventional radio. The on-air polarity determines whether the transmitter sense line is active high or active low. It is also used for the local mic repeat function to know when the mobile microphone is keyed. The audio paths to and from the mobile radio can be either flat or filtered. The transmit audio path is the audio leaving the SVR-200 going to the mobile. It can be either flat or de-emphasized. The receive audio would be the audio coming from the mobile that is going to be rebroadcast to the handheld by the SVR-200 and can be either flat or pre-emphasized. These settings are determined either through the service manual or from the application note that we provide. The system tone frequency is the tone that is transmitted when the repeater is first enabled, and it is used to identify the SVR-200 to the other units in the system. There are three different tones in use: 682.5, 832.5, and 847.5. All of the repeaters in your system must have the same lock tone frequency. Local mic repeat is an option that allows the officer in the field with the handheld to hear what is being said by their partner in the vehicle when that officer is talking to the base using the mobile radio. If enabled, local mic repeat will key the SVR-200 and enable the audio to be heard by the officer in the field with the handheld. Courtesy blip is an option that signals the officer with the handheld that they were successful in reaching the SVR-200 with their portable. The SVR-200 transmits a short beep tone to verify operation. It also lets other users on the channel know that the SVR-200 is clear and can be used. Priority sampling is a feature that occurs during base to portable transmissions. When the mobile is receiving from the base, the SVR-200 is transmitting to the portable. The SVR-200 can be programmed to periodically unkey to check for other repeaters or for handheld transmissions. If another SVR-200 transmission is detected, carrier without tone, the sampling repeater will revert to non-priority status and cease transmissions. If a handheld transmission is detected, carrier with tone, the SVR-200 will reverse direction and repeat portable to base. This prevents the handheld operator from being locked out and also allows them to respond during hilltop repeater hang time. The sampling interval can be programmed from 1/4 of a second to 2.5 seconds in quarter-second increments. When all of the common data items have been properly selected, press Escape to exit the Data Entry menu. Select the File menu and Save function to write the current data to disk before downloading to the radio. In order to download the information to the SVR-200, insert the FY1 programming cable's DB9 connector into the selected COM port of the computer. The other end of the cable will connect to the SVR-200 programming jack P3. The programming jack is located behind the front panel of the repeater. By removing the front panel, we expose the programming jack. Make the cable connection by inserting the 2.5 mm jack into P3, and the option LED will illuminate, indicating that you have a positive connection. With the cable properly connected, we can return to the software and select the radio menu and the Send function. Press Enter to download the data to the SVR-200. When all of the data has been sent, the program will indicate a successful download. In this section, we're going to cover some of the alignment issues with the SVR-200, show you how to disassemble it, and complete the bench alignment. We're going to introduce you to a test fixture that we have developed to assist in the alignment and programming of the repeater. Normally, the SVR-200 would have to be connected to the mobile radio in order to align it. Our test fixture allows us to put it on the bench, power it up, set some of the input and output levels, and simulate the signals coming into the repeater. On the back of the test fixture, we have 2 audio jacks, one that will allow us to inject a signal into the repeater to simulate mobile receive audio, and one jack that will allow us to look at the audio coming out of the repeater. The audio tone output from a service monitor will connect to the test fixture audio in jack. The audio out from the repeater will get connected to a SINAD meter or scope. The test fixture requires 12 volts DC from our power supply in order to supply power to the repeater. When everything is properly connected, activate the SVR-200 by turning on the power switch and setting the Enable switch to the active state. The COR switch is used to simulate the signal from the mobile radio to indicate when it is receiving. And muted. To disassemble the repeater, move the 2 cap screws securing the back panel to the extrusion. Remove the 1 Phillips screw that anchors the heat sink to the case. Remove the repeater from the housing by sliding the entire assembly out of the extrusion, exposing the main circuit board as well as the RF board. The control board contains all of the level adjustments and control circuitry. The daughter board contains the radio portion and all of the adjustments for receiver sensitivity. The 2 boards are mated through connector P2. The power supply section is located at the rear of the control board. The LED indicators are located at the front edge of the control board, as well as the programming jack P3. Connect the SVR-200 to the test fixture by inserting the power cable into P1 on the rear panel and connecting the service monitor to the antenna jack. Three sections of the control board of interest to us are the test jumper J3, test point 1, and test point 2. J3 is located to the right of the microprocessor and is used to activate the transmitter and to put the receiver into open squelch mode. Test point 1, located in front of the daughter board, is the RSSI level, or Receiver Signal Strength Indication. We'll use that for aligning the receiver. Test point 2, an exposed pad on the board near U1, is used for measuring the mobile COR signal. Test point 2 is electrically the same as the violet wire coming from the cable and is a very convenient point to verify the level and confirm that the COR signal from the mobile changes state when the mobile is receiving and when it is muted. With the SVR-200 connected to the test fixture and the service monitor set to transmit frequency, enable the repeater by turning on the test fixture. When the SVR-200 is first enabled, it will transmit the lock tone for approximately 800 milliseconds, then revert to idle mode. To put the SVR-200 into transmit test mode, short jumper J3 with a small metal screwdriver, and the repeater will transmit and send lock tone for as long as you short the jumper. If you remove the short, the repeater goes back into receive mode. The repeater power supply uses the metal extrusion as part of the heat sink. While the repeater is removed from the extrusion, we will need to reduce the RF power output to prevent the unit from overheating during alignment. Power output adjustment is done with RV10 located in front of the mating connector. Turn the power down to 300 milliwatts or less. The first alignment test we will perform is to set the synthesizer frequency. Short the test jumper J3 to put the SVR-200 into transmit test mode. Adjust C851 on the RF board for the transmit frequency plus or minus 100 Hz. Next, we can use the lock tone generator to provide an audio signal in order to set deviation. The lock tone circuit was designed to output a large enough signal to produce full limiting in the SVR-200 modulation circuits. Adjust RV7 for maximum and observe the waveform on the service monitor as the radio goes into clipping. Adjust RV8 for the maximum deviation level, plus or minus 4.5 kHz in this case. RV7 can now be readjusted for normal lock tone level, which is plus or minus 3 kHz. Readjust RV10 for the desired RF output level. The transmitter is now completely aligned except for the audio level coming from the mobile radio, which we'll do after we align the receiver. To align the receiver of the SVR-200, we use the same test point J3. Instead of shorting the jumper after the power has been applied, short the jumper and then apply the power. This procedure will put the repeater into open squelch mode, and we'll be able to hear the speaker audio to aid us in alignment. The output from the SVR-200 will also be routed into the service monitor SINAD meter input and will allow us to make receiver sensitivity measurements directly. In order to adjust the receiver sensitivity, connect a DC voltmeter to test point 1, the RSSI indication output. Adjust the service monitor output for approximately 1 volt DC at this test point. Adjust the 4 front-end cavities for a maximum reading on the voltmeter. When you have peaked all 4 cavities for a maximum reading, the receiver will be tuned for best sensitivity. Reduce the service monitor output until the SINAD meter reads 12 dB. This is the reference sensitivity for the repeater. The VHF SVR-200 is aligned in the same fashion. Connect a DC voltmeter to test point 1 and adjust the service monitor output for 1 volt DC. Adjust the 4 front-end coils for a peak reading on the DC voltmeter. When the receiver is properly aligned for best sensitivity, the next adjustment is the repeater squelch. The third LED from the left is the repeater COR indication or squelch indication, and we want it to be active only when receiving a valid signal from the handheld. The very minimum setting we want to adjust is for 0.5 microvolts. This setting may need to be increased if you have co-channel interference or the ambient noise level is higher in your location. To set the squelch threshold, adjust the service monitor output for 0.5 microvolts and adjust RV9 until the COR LED comes on. Verify that when the RF level is reduced to 0.35 microvolts, the COR LED is off. In order to complete the bench alignment of the SVR-200, we will want to verify operation of the sub-audible tone detection. In order to do that, we need to return the repeater to normal operation. Reset the repeater by turning the test set off, then on. With the service monitor in generate mode, increase the RF output until the COR LED indication is on. Turn on the sub-audible tone generator and confirm that the repeater tone LED is illuminated. On the test fixture, the push-to-talk LED confirms the SVR-200 would be keying the mobile. This completes the bench alignment of the SVR-200. The only tests remaining before putting the unit into service is to set the audio sensitivity levels using the actual mobile radio it will be connected to. In order to adjust the audio sensitivity levels, 2 service monitors will be required, as well as the mobile radio the SVR-200 will be connected to. Put service monitor number 1 into generate mode on the mobile receive frequency, 1 millivolt RF output with plus or minus 3 kHz deviation. Connect the service monitor to the mobile radio antenna jack. Service monitor number 2 is connected to the SVR-200 in monitor mode. Connect the SVR-200 to the mobile radio and enable the repeater. Verify the mobile is receiving the signal from the service monitor number 1. Connect a DC voltmeter to test point 2 and record the reading, in this case 5 volts. Switch service monitor number 1 to monitor mode and record the reading at test point 2, in this case 0 volts. Move the voltmeter to the center pin of RV1 and adjust RV1 for a reading midway between the 2 readings taken at test point 2, in this case 2.5 volts DC. Switch service monitor number 1 back to generate mode and confirm the SVR-200 is transmitting. If the SVR-200 does not transmit when the mobile is receiving, but is transmitting when the mobile is muted, the COR polarity is programmed backwards. We have disabled priority sampling in the SVR-200 in order to more accurately adjust the audio level. Adjust RV5 on the SVR-200 control board for a reading of plus or minus 3 kHz on service monitor number 2, so that 3 kHz in gives us a 3 kHz out in base to portable mode. To adjust the audio sensitivity and the portable to base mode, Switch the service monitor connected to the mobile into monitor mode. Switch the service monitor connected to the SVR-200 into generate mode, 1 millivolt RF output with plus or minus 3 kHz deviation of 1 kHz tone and plus or minus 600 Hz deviation of the CTCSS. Confirm the SVR-200 repeater COR and tone LEDs are illuminated and the mobile radio is transmitting. Adjust RV3 on the SVR-200 control board for plus or minus 3 kHz deviation as read on the service monitor connected to the mobile. This completes the alignment section of the SVR-200. In this next section, we want to cover the basic operation of the repeater and learn how to use the front panel LEDs to verify proper operation or to diagnose problems we may be having. When the SVR-200 is first enabled, it will check the channel for activity and, if it's clear, will transmit the lock tone for approximately 800 milliseconds, then assume priority status and return to idle mode. In idle mode, the CPU LED will blink and the priority LED will remain illuminated. When the handheld transmits, the repeater COR and tone LEDs illuminate, and if we are at priority status, the mobile transmit LED will also illuminate. This is portable to base mode. Releasing the handheld push-to-talk returns the SVR-200 to idle mode. When the mobile radio receives a signal, the mobile COR and repeater transmit LEDs illuminate and the SVR-200 begins repeating to the handheld. This is base to portable mode. If priority sampling is enabled, the SVR-200 will periodically unkey to check for handheld activity, carrier and tone. If a handheld were to transmit, the SVR-200 will detect its transmission during one of its sampling intervals and reverse direction. If, during base to portable mode, the SVR-200 detects carrier without tone, it will pause. If carrier is not detected within 800 milliseconds, the SVR-200 will revert to non-priority status and cease transmissions. This is the self-clearing mechanism in case two SVR-200s are at priority. One of the repeaters will unkey first and detect the other. The first one to sample will remove itself from priority, even though its mobile is still receiving and the mobile COR LED is illuminated. As long as the non-priority repeater senses that there is another priority repeater on scene, it will remain at non-priority status. If the priority repeater were to leave or become disabled, and a condition to repeat were to occur, the non-priority repeater will not detect the presence of the priority repeater, and after approximately 800 milliseconds will assume priority and begin repeating. In the presence of co-channel interference, or if the repeater squelch control is set too light, the SVR-200 can be fooled into thinking there is another priority repeater on site. We have adjusted RV9 so that the repeater's COR LED is always on. When the SVR-200 repeats base to portable mode and sampling is enabled, it will falsely detect carrier without tone during the first sampling interval. According to the rules of operation, the SVR-200 must remove itself from priority and cease transmission. The handheld operator will hear only the first few words from the base, and then nothing. In order to work properly, ensure that the repeater squelch is set high enough so that it isn't fooled by ambient noise or co-channel interference. If set properly, the repeater COR LED will only come on when the handheld is transmitting. Another commonly occurring condition is when the repeater is stuck in transmit all of the time and the front panel shows the repeater transmit LED without mobile COR indication. This indicates local mic repeat mode, and the SVR-200 thinks the mobile microphone has been keyed. If enabled in software, the SVR-200 can detect when the mobile microphone has been keyed, and audio from the officer in the vehicle will be repeated by the SVR-200 to the officer with the handheld in the field. If the front panel LEDs give you this indication and the mobile is not keyed, most likely J5 has not been installed, or the polarity of the on-air detect line is programmed incorrectly. A common problem experienced when the SVR-200 is in the same frequency band as the mobile is RF interference, or desense. It is most common when the two antennas are located in close proximity to each other, or the transmit frequency of the mobile is too close to the receive frequency of the SVR-200. The symptoms can be a loss of range or phenomenon known as picket fencing. When the officer keys their handheld, the SVR-200 is able to receive the transmission and will key the mobile radio. The high power of the mobile transmitter will swamp the receiver of the SVR-200 and desensitize it, reducing its effective range. The SVR-200 may no longer be within range of the handheld and will drop the call, unkeying the mobile. With the mobile no longer transmitting, the SVR-200 is returned to normal sensitivity and can once again receive the portable, which will once again cause the mobile to transmit, desensitizing the receiver, and the cycle repeats. The test method presented here will allow us to determine if there is desense occurring and will allow us to measure the degree of desensitivity and the effectiveness of any steps we take to reduce it. Using the test fixture, we will place the SVR-200 in the open squelch mode and monitor the channel through the speaker output. The vehicle antenna will be connected to the SVR-200 through a T connector, with the other end of the T going to the service monitor. Adjust the service monitor output for 12 dB SINAD. In this case, approximately 0.3 microvolts. Key the mobile transmitter using the local microphone and key any changes in the receiver audio of the SVR-200. From the SINAD meter, we can see the sensitivity is dropped. By increasing the output of the service monitor until the SINAD meter once again reads 12 dB, we can measure the amount of desense, in this case about 0.6 microvolts or 6 dB. The simplest cure is to move the antennas further apart. When the mobile is transmitting at a high power, it can radiate directly into the receiver antenna. We want to separate them as much as possible to isolate the transmitter from the receiver. By separating the antennas, you can see that there's no difference between when the mobile is transmitting and when it is not transmitting.